All right. Let's think about Schumpeter model today together. So actually, Schumpeter was a person in 19th century. His name was Joseph Schumpeter. He coined the terminology creative destruction. This terminology describes how the incumbent firms or incumbent products are constantly replaced um, with new products and new firms by innovation. So the researchers whose name was Aghion and Howitt, who just won the Nobel Prize this year, developed their economic, growth model with innovation, and they showed their respect to Schumpeter by coining their model follows Joseph Schumpeter's name. So this Schumpeter model is actually a bit complicated, but I wanted to show you more simplified version. So I formulated it as a simple extension of Romer model. So in the Romer model, the R&D, the innovation of ideas are always successful. So if you just do some research, then boom, you get the new ideas. However, in the Schumpeter model, that is not the case. Sometimes you success, sometimes you fail to create new ideas or valuable ideas. So that is reflected to this Schumpeter model. So it is also called the stochastic growth model. So let's see. As in the Romer model, excuse me, population is fixed and the number of workers in the manufacturing sector versus R&D sector is also fixed. So population, the entire population is given by capital L, and the number of researchers is given by the share of researchers among population and multiplied by the entire population. Then this means that um, the rest, 1 minus little l times capital L, is the number of workers in the manufacturing sector. Also, the Schumpeter model features a variety of or multi-product. So they will be indexed by numbers like 1, 2, 3, 4. But anyway, since it's indexed, I will use I for individual product. So each individual product can mean some menu of food like hamburger, pizza, or bibimbap, etc. So these are like product of index I at time t. And each product has some quality, and this quality is denoted by A sub IT. This is the quality of product I or menu I, the hamburger's quality. So the amount of or value produced in the economy for hamburger is the quality of hamburger times the workers in the whole whole hamburger sector, whole food sector. And I assume that the workers in the manufacturing sector are actually shared across the industry. So I just fixed the number of workers for each production, each production of variety. All right, that is the production function. And we have now the primary difference of Schumpeter model from the Romer model. In the Romer model, again, the R&D was always successful. So there was always the next level of technology or next level of ideas. But in the Schumpeter model, that could not be the case. It could be successful or may not be successful. If R&D is successful, then it achieves the target level of quality, A star, in the next period, T plus 1. And that would be some development from the current level of quality or some improvement of current level. So this is the current level of quality. And because there will be improvement, it is multiplied by 1 plus the growth rate of this quality production. So from here, if we derive the innovation or changes in the quality, then that is exactly same to the Romer model, because this is only the case of success. So the changes in quality of product I toward the next period would be, this is just the difference, A star minus AI at time t, and that is A sub IT multiplied by, ignore 1 because it was on the left-hand side now, and Z times the number of researchers in the economy. Let's ignore the time script t because it's fixed. Then this is again quality of product I at time t times Z times the number of researchers that is shared in this economy. Okay, so that is the changes in quality of product I when R&D is successful. And then the growth rate would be the change over the previous level. So, as in the Romer model, this is Z, the research productivity times the share of R&D sector workers times the entire population. And we defined this multiplication of 3 parameters as G, the growth rate of technology or growth rate of ideas. And this is the case for successful R&D in the Schumpeter model. Okay. What if R&D is not that successful? Then the quality of the product next period will be the same to the current level of quality. So there will be no change in this case. So it's null. So the change is 0. Okay. And the success and failure is actually random. So there is a probability of success given by the Greek letter mu. Then we can compute the expected quality of product next period. So expected quality we'll have this expectation operator for the quality next period, and that is the probability of success and the quality when it was successful, and probability of not success or failure times if the R&D is not success, then the quality is the same to the current level of quality. So we multiply the current level of quality there. Hence, we just plug in the target quality when it is success. So this is the target quality in terms of current quality. And if we arrange the terms, then we have this one. It looks very similar to the case of Romer model. One difference is that we have mu, the probability, in front of the usual growth rate, or the successful R&D's case growth rate. Okay, so that is confirmed in the next calculation. The expected growth rate of quality would be the growth rate with the expectation operator, and that is probability of success times growth rate when it is successful, plus probability of failure times when, the growth rate of quality when it's not successful. That is just 0 because there will be no improvement when R&D is not that successful. So we can ignore the second term. We can focus on the first term, the success case. Then we just multiply the probability of success mu times the growth rate when R&D is successful, which is the growth rate of Romer model. So we have expected growth rate of quality mu times G. Then this is related to expected growth rate of output per capita. So when economy actually experience quality improvement, then economy experience this much growth rate. However, if there is no successful quality improvement, then growth rate will be 0. So actual growth rate is jumping around. It's either G or 0. However, the average will be like this. Average will be in between these jumps. Okay, so the average will be mu times G, and the dots are the actual growth rate of the economy. And if we draw the changes of quality or changes in output per capita over time, then again, it's jumping around. So it looks like staircase, and there are some stagnated period of time that the economy does not have any successful quality improvement, but suddenly grows again. There are a lot of jumps in quality, and then it experience or stagnated quality of products. But anyway, if we trace the trend of economic growth, then that would be, looks like this, going through this staircase. And the slope would be mu times G. Okay? So that was the Schumpeter model of stochastic growth. I hope it was helpful. Thank you for watching.